different frequencies. Now this TDMA, time division multiple access, where the entire bandwidth is divided into particular time slots, and each and every user can use a particular time slot to transmit the data or voice. Next, this CDMA, code division multiple access. So in this code division multiple access, the entire bandwidth will be available to every user, but we will be using a PN sequence, pseudo sequence, through which the user can access the entire bandwidth. So this is OFDMA, orthogonal frequency division multiple access, where the carriers like subcarrier, many of subcarriers will be there, and each and every subcarrier will be orthogonal to this one. So which will reduce our guard band in interference also. So OFDM is the state of art and most efficient and robust interface, air interface. So in this orthogonal frequency, what we are using, the entire bandwidth will be divided into subcarriers. Each and every subcarrier will be orthogonal to each other. So interference will be very much less and the efficiency will be more. So this one, like LTE air interface. So while communicating through our E node B, uplink, downlink, like while we are communicating through our E node B, we'll be using OFDM, which is downlink multiplexing. OFDM stands for orthogonal frequency division multiple access. The receiver complexity is at a reasonable level, and spectral efficiency is there. Interference is low and very well suited for MIMO. Next, this single carrier FDMA, this is used for uplink multiplexing. Like while we are transmitting data to the E node B, we are using this one. And this SCFDMA stands for single carrier frequency division multiple access, a variant of OFDMA only. The advantage is to have a lower PAPR, peak to average power ratio. And now the power efficient uplink increases battery lifetime. Like battery does not get drained, and efficiently we can use the battery so that user need not charge every time. Often reduce terminal complexity. So what is this EPS? Evolved Packet System. So like we are having the user equipment over here, the evolved UTRAN, which is E node B. Next, this EPC and UTRAN. So this E node B is connected to serving gateway, which is in turn connected to MME. This one connected to HSS. This architecture I have given in the previous thing also. The evolved packet core. This is under release 8 only. This has access to our external IP networks and performs a number of CN related functions like QoS, quality of service, security, mobility, terminal context management for ideally camped and active terminals. So this is evolved UETRAN actually. The same thing. All the radio interface functions will be done by this UTRAN. So this is the main, actually the main architecture, what you call, from the entire 4G, like LTE system. These are the interfaces, like in between this mobile and E node B, we are using UU interface, which is called air interface. And this evolved node B to other evolved node B, X2 interface. Interface is nothing but interconnectivity actually. And from this E node B, we are connecting our MME through our S1 interface. And MME will be connected to HSS through our X6A interface. And in turn, this MME will be connected to serving gateway, packet data network gateway, PCRE, policy and charging rule functions, and packet data networks. So in this way, the user can access, these are the interfaces actually, from one serving gateway to the other packet data network. The interface will be S5 and S8, and this thing like S7 from PDA gateway to PCRE. We'll go to the next. So this is evolved node B actually. So these are the functions like radio resource management, radio bearer control, setup modifications and release of radio resources, connection management, control state management, radio admission control, E node measurements, collection and evaluation, dynamic resource allocation, IP header compression by decompression, MME selection and attach of the UE, user data routing to the serving gateway, transmission of paging coming from MME, transmission of broadcast in the systems. So this is the actually gist of this one. It is the only network element defined in the part of QTran. So it is replacing this E node B is replacing the existing node B, which will be using in 3G node B, and here will be called it as evolved node B. It terminates the complete radio interface, including the physical layer. It provides all the radio management functions and handles various several cells also. Like we can be using 3, 4, 5, 6 cells also. It can be served through one E node B. So this is the mobility management entity, MME. So these are the functions actually. The control plane functions, it will be handled through this MME. And this signaling is through non-access stratum signaling, ideal state mobility handling. It tracks the area updates also. Subscriber attach, it will also be taken by this MME actually. So security, authentication, ciphering, integrity protection, triggering and distribution of paging messages to E node B, roaming control, inter-CM node signaling, and inter-MME tracking updates are also handled by this mobile management entity. So it is pure signaling entity. So it attaches and disattaches the EPS system. It is like PLR-like functionality. In 2G, like we'll be having in the core part, PLR, visitor location register. The same functions will also be taken care of this mobile entity in this 4G system actually. Next, we are going through our serving gateway, which is called SGW. So in this, the main functions are local mobility anchor point. From MME, this will be connected to our serving gateway actually. So which will be acting as an anchor point to our PDN gateway. So this is an interconnectivity also between our E node B and PDN gateway. From MME also, the serving gateway will be connected and packet buffering will be taking place actually. Packet buffering and notification to MME for UE in ideal mode will also will be handled by this serving SAE gateway. It connects to it, the interface also, it was mentioned here. The interface is E node B and serving gateway will be through our S1 interface. And this will be also our E node B and MME will be also through S1 interface. MME and serving gateway through S11 interface. This one through S5 to S5 interface. This one our packet data network PDN gateway. So this packet data network with the terminal actually, the other side. If our UE is our other side, this one is the terminal side of our access point. So PDN gateway functions are like mobility anchor for mobility management between 3G PP access systems and non-3G PP access systems. This is sometimes referred to as SC anchor functions. Actually, this serving gateway is one of the anchor. The next point, it will be transmitted to this PDN gateway. Next, it also supports the charging functions. Like this intern will be connected to PCRE. So through this, the charging functions will also be taken care of. The IP also gets allocated through this PDN also. If an UE is connected simultaneously to several PDNs, this may involve connections to more than one PDN gateway. So if the UE is connected to several PDNs, packet data networks, this will be PDN SCA takes a major role, and it ensures that the UE is handled in a smoother way. The data and transmission happens in a smoother way. So this is the terminal point, policy and charging rule functions. So the QoS policy negotiations will be taken care of this PCRE, determines how the packet should be accounted and how much billing should be taken place. Everything will be through this policy and charging rule function, PCRE. So this will be connected to our serving gateway also through this S6A interface. So this is home subscribe server, HSS. So it is almost like our HLR in our 2G network. So this HSS functions are permanent and central subscriber database, stores mobility and service data for each and every subscriber, and contains the authentication center. Like in the previous things, we used to have authentication separately, and every function will be taken care separately. But in this HSS, these all were integrated features actually. So authentication is integrated, and the database regarding the end subscriber, like what are the plans he is using and how the access will be and how much speed should be given to the subscriber. Everything will be fed up in this HSS actually. So now we are going to our channel bandwidth. Like previously I told, like different types of bandwidths are being used. So 1.4, 3 megahertz, 5 megahertz, 10 megahertz, 15, 20 megahertz. And these are different types of this thing. And each and every band can be divided into subcarriers. Actually, this 20 megahertz thing can be divided into 15 kilohertz subcarriers around next 3. This is our 3GPP spectrum. So uplink will be 1920 to 1980 megahertz. Downlink is this one 21002 to 2110 to 2170. FDD, frequency division duplexing, we are using. And now, like previously I have told, 2500 spectrum also it is being supported. So these things through TDD. Actually, the main thing is like in this TDD, the penetration will be low. So around we can expect the radio access around 300 to 400 meters only. Whereas in this 824 to 850, we can expect around 4 to 5 kilometers of penetration. So this 2500 megahertz spectrum will take mainly care of dense type of users, whereas this 800, this thing will be taking care of villages type population, like where the population is sparsely populated. Like this, now orthogonal frequency division multiple access. Like I have told previously, each and every carrier, subcarriers will be available. Each and every subcarrier is around 15 megahertz bandwidth, and these will be separated orthogonally so that there will be no interference. So there will be no requirement of guard band in this OFDM technology. Whereas in the FDMA, we will be using guard band. Like if you are using the nearest bands, we will be using one guard band so that it will be separating the two bands. But in this OFDMA, what is the feature is that we will be using orthogonally so that carriers does not get interfered and more spectral efficiency you can use. So the channel bandwidth is divided into lower bandwidth subcarriers. Each subcarrier operates at a different equally spaced center frequency. Bits are modulated and transmitted simultaneously on each data subscriber using a symbol time. So this uses, like I have previously told, OFDMA technique will be used in our downlink, and single carrier FDM will be used in our uplink transmission. So channel direction I have given. So our E node B, this is UE, like end user, and this is UEM. So this is our downlink. Downlink is from our E node B to the user. Uplink will be from our user to the E node B. So in this it was written, downlink is from E node B to UE. Uplink is always from UEs to E node B. DL and UL bandwidth is shared by all the UEs in the cell sector. DL and UL may operate on same TDD or different frequencies. This is our downlink and uplink slide. So after this LTE, we are going, which is release 8. Now we are going to the advanced version where we can improve our speeds, where this LTE Advanced, which are release 10 and 13, this LTE Advanced Pro, release 13 and beyond. So you can see here, like in LTE release 4, there is our normal 4G, we are getting around 150 Mbps with 10 milliseconds latency. So where we are going to this LTE Advanced Pro, the data grades improves by 10 times. Lower latency 10 times. Larger cover will be 10 times. Battery life will be 10 times. Lower Internet of Things cost, more capacity. So which will enhance our capacity and will increase our new service capabilities also. This is one of the advantage beyond this LTE. So we are going for this LTE Advanced Pro. And this LTE Advanced Pro will all automatically in the release 16. So the developments will enable the Internet of Things, vehicular communication, intelligent traffic. Nowadays, like everyone is installing GPS in their cars and everything. So the tracking and all will be very much possible through this LTE Advanced. So the key attributes of this LTE Advanced are data speeds in excess of this 3 Gbps. Previously, we were talking about 1 GB in LTE. Now, in this, we are talking about 3 Gbps. And this 640 megahertz of carrier bandwidth. Latency is around 2 milliseconds. Previously, like LTE, we are talking about 10 milliseconds latency. It got decreased by 2 to 3-fold. So now, like 5G, this is an advanced version of this Advanced Pro we can talk. Like this will be 100x faster. With 4G, it takes almost 6 minutes to download a full movie. The same movie can be downloaded in about 15 seconds with this 5G actually. So it is becoming around 100 times faster than our normal LTE and advanced LTE. So, and 100 times more devices can be connected using this 5G thing. 5G will be able to connect about 500 times more devices, including everything from baby monitors, cars, smartphones, drones, VR headsets, and more. So the responsiveness will be around 5 times. So 5G's low latency or quick reaction will break through in real-time applications in real-time. So we can get any data within a second's time, actually, milliseconds time. Around the latency has now improved to around 1.6 milliseconds, which is around, which it has reduced by 5 times from our LTE and LTE Advanced Pro. So these are the features of our 5G technology. So around, we are talking about virtually zero latency. So I'm telling theoretically it is around 1.6 milliseconds. Like in a split of a second, you can visualize the things. As soon as you type the browser or any video, in a split of a second, we can able to visualize the things. So speed has improved to around 10 gigabits, which was around 1 gigabit in our 4G Advanced Pro and 4G. Now it has improved to 10 gigabits. So using this 5G, we have access to a wide range of applications, ubiquitous connectivity, and more software options to upgrade. And it supports very high capacity and fast response time. And 100 times more devices can be connected, which was shown in our previous slide. So this one I have kept for just your understanding. 5G system. This one like our user equipment, which is an air interface. It is just a basic demonstration only, not on depth. This one like our user equipment will be connected to our radio access network, which is the access network, and it will be interconnected to our 5G core network. And this 5G core network will be interconnected to our data network cloud actually. So this is the brief comparison of all our 2G, 3G, 4G, and 5G technologies. Like here you can see in 2G, which was introduced in our 1993, and 3G has been introduced in 2001, 4G 2009, and 5G, which is around release 16 plus, 3G release plus 16 plus in 2018. The technology we are using in 2G is GSM, 3G is wideband port division multiple access, and for 4G, LTE and WiMAX. Here WiMAX we are calling it also 4.5G actually. And this 5G we are using MIMO and MM waves. And for access system, for 2G we are using TDMA and CDMA, and 3G we are using WCDMA, for 4G WCDMA, and for 5G OFDM and BDM. Switching type, like for 2G, circuit switching for voice and packet switching for data. For packet, and 3G packet switching except for air interference. And for 4G packet switching, 5G is packet switching. So these all things will be only packet switching. Our 2G voice and all will be through IMS actually, IP multimedia system. So internet service of 2G is through narrowband, 3G is through broadband, 4G is ultra broadband, 5G is through wireless World Wide Web. Now going to the bandwidths actually. For 2G, 25 megahertz bandwidth. So 2G is, we are using paid spectrum actually. So 25 megahertz, there will be a difference between our uplink and downlink frequency, which will the frequencies will be paid actually. And in 3G, we are using 25 megahertz bandwidth only. For 4G, 100 megahertz bandwidth. And for 5G, we are going to 30 gigahertz to 300 gigahertz bandwidths. So what are the advantages of all these features we will be seeing? So advantages, multimedia features like SMS, MMS, internet access, and SIM introduced. This is the basic things in our 2G. Now it got improved to high security and international roaming in our 3G. And for 4G, it has even enhanced to speed, high speeds, handoffs, global mobility. And for 5G, we are talking about extremely high speeds, low latency. The high speeds, which I have talked really theoretically about 10 gigabits, we can expect actually. And the latency around a split second, around 1 millisecond. And for applications, for 2G, we are using voice calls and short messages only we use it to use. For 3G, we are using for video conference, mobile TV, GPS. And for 4G, high-speed applications, mobile TV, wearable devices, for 5G, high resolution video streaming, remote control of vehicles, robots, and medical procedures. In future, this will come into the practice. So this is all about our evolution from LTE to our 5G actually. So I have two more videos actually, very small videos, which I would like to play for just our understanding.
Mobile network technologies has evolved over time to satisfy the increasing customer needs for higher data rates and better services. In brief, the mobile station you are having should be able to make voice calls, in addition to data sessions. The voice calls in the mobile network are using the circuit switching, CS domain, while the data sessions are using the packet switching, PS domain. In order to understand different mobile network technologies, let's take a quick overview on the organization that developed those technologies. 3GPP is the organization that manages and develops mobile network standards. Those standards cover all aspects of mobile networks. In 1997, 3GPP introduced Release 96 of the standards. In this release, the GSM technology existed. GSM had only a CS domain that passed voice calls, while it didn't support data sessions. Therefore, in 1998, 3GPP introduced Release 97 of the standards, in which network architecture enhanced to support data sessions. This is done by introducing GPRS, General Packet Radio Service, which contains a PS domain to pass data sessions. To sum up, the core network describes the combination of the CS domain and the PS domain in mobile network. The mobile station connects to the core network through the access network, which controls the communication between the mobile station and the core network. The access network name in GPRS is GRAN, which refers to GSM, Edge, Radio Access Network. In fact, this whole network that contains the access network and the core network forms the second generation network, or 2G network. In order to afford higher data rates and better utilization for network resources, 3GPP introduced Release 99 of the standards, and this was in year 2000. In this release, the third generation, 3G, network existed. UMTS, Universal Mobile Telecommunication System. In fact, this is the term used as an umbrella for the third generation technologies. UMTS is having both a CS domain for voice calls, in addition to a PS domain for data sessions. The core network of UMTS is inherited from GSM GPRS network. Actually, the access network for the 3G network is the UTRAN, which refers to Universal Terrestrial Radio Access Network. In fact, GPRS afforded PS service to mobile networks. Therefore, you may find it mentioned in two different manners. First, GPRS along with UMTS. This means GPRS refers to 2G network, while UMTS refers to 3G network. Second, GPRS alone. In this case, GPRS refers to PS service in both 2G and 3G networks. This is because the core network in UMTS is inherited from GSM GPRS network. After that, 3GPP introduced Release 8 in year 2008. In this release, long-term evolution, LTE existed. It is the fourth generation, 4G, network. Unlike previous generations, LTE network is having only a PS domain in the core network, while it doesn't have a CS domain for voice calls. The mobile station can make voice calls by connecting to an external network, which is the IMS network. The mobile station connects to the IMS network through the PS domain. In addition, the PS domain architecture enhanced and named the Evolved Packet Core, EPC. The access side of the LTE network is the EUT-RAN, which refers to Evolved UT-RAN. In later 3GPP standards, Release 14 and 15, 3GPP introduced new technologies like Internet of Things, IoT, and fifth generation, 5G network. mobile networks evolved over time to afford better services. First came the 2G network, which is the GSM GPRS architecture, which contains a CS domain for voice calls and a PS domain for data sessions. Then came the third generation network, UMTS. UMTS inherited its core from the GSM GPRS architecture. Therefore, GPRS term can be used to call the PS domain in both 2G and 3G networks. After that came the 4G network, which is the LTE. The LTE network contains only a PS domain, which is the Evolved Packet Core, EPC.
We are having one more video for this one. I will be playing that also.
సారు లీవ్ అయినట్టున్నారు.
Ma'am, any issue, ma'am? Lakshminarayan, ma'am?
అదే సార్ జగదీష్ సారు కట్ అయినట్టుంది, మళ్ళీ జాయిన్ అవ్వాలి.
ఓకే నేను ఒకసారి రిమైండ్ చేస్తాను మేడం. నేను ఇప్పుడు జాయిన్ అయ్యాను.
జస్ట్ వీడియో ఆన్ చేస్తానన్నారు, అంత లోపల ఏమన్నా కట్ అయిందో ఏంటో అర్థం.
అదే తెలియకుండా కట్ అయింది. జస్ట్ 2 minutes మేడం, నేను మాట్లాడతాను.
ఓకే.
హలో చేస్తున్నారండి, వస్తుంది ఒక నిమిషం.
ఓకే సార్, ఓకే. థ్యాంక్ యూ లక్ష్మీనారాయణ గారు.
Okay, sorry, like we have some technical disturbance. Now I am starting
No issue, sir.
second video.
Welcome to this lesson. In this lesson, we will learn network architecture of LTE. This diagram shows LTE network architecture. LTE refers to long-term evolution, and it is used to refer to the fourth generation 4G mobile network. In order to understand LTE network architecture, we need first to understand the difference between the control plane and the user plane. The main target of the LTE network is to connect the UE to an external network so that the UE can send and receive data to and from this external network. Simply, the control plane is used to exchange signaling messages between the nodes. Signaling messages are used to control the data session of the UE, while the user plane is used to exchange user data between the nodes so that the UE can send or receive user data to and from the external network. After we learn the difference between the control plane and the user plane, let's discuss network architecture of LTE. LTE network contains the access network and the core network. The access network is called Evolved UT-RAN, and it contains the eNode Bs, while the core network is called the Evolved Packet Core EPC, and it contains the MME, SGW, the PGW, and the HSS. First, the UE connects to the eNode B. The eNode B provides the radio interface for the UE, and the eNode B connects to the MME. MME refers to Mobility Management Entity. The MME is the entry point for the Evolved Packet Core. It performs authentication and security. The MME authenticates the UE and performs security procedures in order to secure the messages sent and received to and from the UE. In addition, the MME tracks the location of the UE and performs admission control, which means it decides if the UE is authorized to access this network or not, and if network resources should be allocated to this UE. The MME connects to the HSS and the SGW. The HSS refers to Home Subscriber Server. It contains a database that stores the subscription information for every user in the network, while the SGW refers to Serving Gateway. During session establishment, the MME will exchange signaling messages with the eNode B and the SGW, and will instruct the eNode B and the SGW to establish a tunnel to directly pass user plane data between each other, so that user data will move directly between the eNode B and the SGW without passing by the MME. Therefore, the SGW is the first point in the Evolved Packet Core that receives user plane data from the eNode B. In turn, the SGW serves as the mobility anchor point for user data while the UE is moving between different eNode Bs. Then the SGW connects to the PGW, which refers to PDN gateway. The PGW connects between the core network and the PDN. Finally, the PDN refers to public data network. It is the external network the UE connects to, if it is the internet or any other network. In summary, the nodes will use the control plane to pass signaling messages between each other, and the path of the signaling messages will be from the UE to the eNode B, which provides the radio interface for the UE. Then from the eNode B to the MME, which performs authentication and security, and tracks the location of the UE, and performs admission control. Then from the MME to the HSS, that stores subscription information for every user, and the SGW, which serves as mobility anchor point for user plane data, and the SGW connects to the PGW, which connects between the EPC and the PDN. While the user plane is used to pass user data sent and received between the UE and the PDN. The path of user plane data will be as following: from the UE to the eNode B, then from the eNode B to the SGW, and from the SGW to the PGW, then from the PGW to the PDN. Thank you and see you in the next lesson.
So, madam, that comes to the end of this slide session and videos, madam.
Thank you, sir. Nice presentation, nice videos, sir. Really valuable videos. So this is the end of the program. It's very valuable and informative sessions, sir. So you addressed so many activities in mobile devices. Particularly, I thank to Tirupati people, Lakshmi Narayana, marketing manager. I approached him, and Tirupati administrative people requested you, and you accepted this invitation. So really, it's very nice, sir. If it is possible, we will arrange physical meeting also, sir, whenever you will come to Tirupati. So if you interact electronics and communication students, actually this is summer holidays. Most of the students are in holiday mood also. but communication and electronic engineering students need this knowledge very much. So thank you once again for accepting invitation and gave attractable and informative message to us. So I once again thank to coordinator Munisankar and students. So try to join more this type of sessions to improve your knowledge. This is the real knowledge, how the differences between all these things. So sometimes you have to acquire more knowledge from this type of webinars. So
Thank you, madam.
once again, thank you, Jagdish Kumar Garu and
Jyoti ma'am,
Lakshmi Narayana Garu.